Alrighty, friends. So welcome back. Let's get into talking about the various global impacts of climate change. So, as stated previously, this is certainly not an all exhaustive list by any stretch of the imagination. There's certainly way more impacts felt all over the world. But the ones that I'm going to kind of focus a bit more on and have a bit more attention are the ones that are a bit more associated with the oceans in particular. Especially because if you're watching this for the oceanography class, it's for oceanography. But also, in my own passion and my own belief, is that the oceans are our lifeline, right? And so if we lose the oceans to how we know them today, to hold and be able to sustain the life as we know it, that's why I kind of focus on that. So if we lose the ocean, we lose everything we know. Basically, is my belief with that. So with that, there we go. Just gonna need to go back a few. There we go. Slides here. So some of the ones I've already touched on in terms of the IPCC synthesis report. But some ones that I won't actually touch on deeper in the next bit of time here are the decreased biodiversity and ecosystem changes. That's something that's pretty wild. We'll talk about biodiversity later on in the semester, but it basically means a great abundance or a lot of different types of species and creatures and living things on the planet. And so basically we have a helping hand in the sixth mass extinction, so that is decreasing the biodiversity of our world. One I also don't really get into is the increased intensity of hurricanes and frequency of severe storms. This is still trying to be better understood, but it is still very impactful. Accelerated spread of disease. Also a concern is diseases that have been trapped away in the permafrost, which is now starting to thaw out. So the permafrost is mostly in northern Russia and the Siberian tundra. And so diseases have likely been trapped in that ice and in that frozen land, permanently frozen land, relatively speaking, that our bodies have not been able to synthesize for thousands of years. So our bodies are not used to it. Similar to how COVID hit us all, right? It's it has impacts. Also changes in seasons and the slowing of the thermohaline circulation. So there's these theories that seasons are kind of shifting, right? So when they start, when they stop is we believe is shifting a bit. And if you've seen the movie A Day After Tomorrow, which I think I've referenced several times throughout the semester, the whole premise of that is the slowing of the thermohaline circulation. If you are a fan of world destruction, natural disaster movies, go see Day After Tomorrow. It's fantastic. By go, I mean you have to, I think, stream it because it's certainly not in theaters anymore. Changes in crop yields is pretty intense too. Kind of mentioned that previously. But also considering things like decreased fresh water supply. I know I mentioned earlier, but still kind of wild. Again, thinking of Mad Max or Dune, where you're really fiending for water resources, that kind of thing. So diving a bit deeper into some of these other ideas, starting with the changing Arctic. So our Arctic sea ice has been on the decline since we've been observing it pretty heavily. And we, not only that, but also plant growth has been observed further north than it used to be because it's warmer, right? So if there are warmer conditions, then plants can grow further, right? Even also, I forgot to mention in the accelerated spread of diseases, something else to consider are pests and pests that can carry diseases, much like mosquitoes or rodents. If the climate is more able to hold or to allow these things to migrate, then you're going to also then be able to expose the peoples who live in that area to potential diseases and such, which is also very concerning. So back to business. 4 to 6 degrees latitude, we can actually splice up latitude and longitude into distances. So 1 degree of latitude is roughly 111 kilometers. So 4 to 6 degrees equates to about 250 to 430 miles. And that's about the distance from San Francisco to Los Angeles. So that's a pretty large distance, right? And also there is the concern that the permafrost not only is containing trapped diseases, but also it has trapped methane and carbon dioxide, which is then being released into the atmosphere, essentially being a ticking time bomb, basically, of those. Still sticking with the ice. So this is changing land ice. So this is looking at the Antarctic and Greenland. So we've put up satellites to help better observe our planet. And this particular mission, this is from NASA, looking, there's a certain subset of satellites, these are called GRACE satellites, which look at Antarctica and Greenland specifically. So you can see the very steady decline here. And the gap in the data in about 2017 is just a time between missions. So satellites come back down and get relaunched. I know that this snapshot of time is not very long, right? It's only 2002 to relative present. However, we can still see a very decent downward trend here. And the reason that we're really concerned about land ice melting is due to sea level rise. So why could all of this, why could all of the Arctic and Antarctic and Greenland land ice, how could that be changing so rapidly? Something called black carbon is very prevalent now. So black carbon is essentially soot, which is generated by combustion processes and fires. And then as it moves around the world and then eventually deposits onto the ice, then it changes what the ice looks like. The ice is no longer white and extraordinarily reflective. It is now absorptive of solar energy. Think about if you put like a white t-shirt and a black t-shirt out in the sun, which one is going to warm up faster? The black t-shirt. The idea here is still the same. So it can accelerate melting. It can basically act almost like a little magnifying glass, allowing for the melting to just quicken in that particular region. So again, why do we care about all of this? Because of sea level rise, especially because we here live near the oceans, right? We live on the coast. So sea level rise is basically due to two main ideas here. One is thermal expansion. So warmer things are less dense. They take up more space. They're loosey-goosey. The molecules are having a dance party, so they're expanded. They're larger. If you've ever boiled water or made soup on the stove or something, you can see how levels increase as it gets warmer because it's bouncing around a bit more. And that's thanks to warmer atmospheric temperatures as well. Then we have melting ice glaciers. So with very, very few exceptions, glaciers around the world have been melting at unprecedented rates. And a really, 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 really important point here is that sea level rise is due to land ice melting. Land ice, big distinction. So all of that fresh water that's being stored on top of a continental piece of land, so Greenland and Antarctica, that's what is kind of honing in on this idea of sea level rise, not sea ice. So yes, we're concerned about the North Pole sea ice melting because polar bears and other animals that rely on the ice to rest, to breed, that kind of thing. But yeah, that's not what's contributing to sea level rise. Think about it. If you have like a glass of ice water, I don't in front of me at the moment, but if you have a glass of ice water and you set it out and let the ice melt, your glass of ice water is not just going to spontaneously start overflowing, right? Because the ice is already in that system. But if you have a full glass of water and try to add ice into it, it's going to overflow because it's not in that system yet or already. However, because sea level rise is a gradual phenomenon, coastal residents are going to overlook these impacts. It's kind of like if you put a frog in a pot of water and you can watch it boil to death and it won't even know, because if you just let the water warm up slowly, then the frog acclimates. So yeah, this is where you can be like, well, the sea has always been this high level, blah, blah, blah. Or they can be like, well, it's just erosion. It's not sea level rise. So this is why we need instruments and measurements to help eliminate something called situational bias or confirmation bias, right? So that's a really big aspect and part of science. So this graph here is looking at sea level rise from 1900 up until relative present. And so what we can see here is, sea levels increasing for sure. And the y-axis here is looking at millimeters. So not only are we looking at, and our tide gauges are the ones confirming this, but satellites are also being used to help confirm this idea as well. So we're using multiple sources of information, multiple methods of being able to tell us this result, and they're agreeing, right? If they were to disagree, then we'd be like, oh, okay, something's a little bit off here, but they're agreeing, right? They are agreeing. So what does this look like? It's kind of hard, I think, to really visualize what sea level rise could look like, especially for low-lying areas. So this website called Climate Central has a decent source to overlay this information onto a map projection. So what we're looking at here is, it really bugs me, it bugs me a lot actually, that the color of the potential area of potential flooding or being encapsulated in water is the light blue, which is very, very similar to the light blue that Google Maps has. So it's not my favorite. And then the red is indicating of 3 degrees Celsius of global warming and the projected sea level rise due to those things. So, I mean, if anyone here wants to, purchase some land in Lodi so you have nice coastal property, go for it. But these low-lying areas are the ones that are in peril. Notice kind of along the coast, like up in Bodego Bay or even Mill Valley, Daly City, Half Moon Bay, etc., there's not as many impacts here because it's really, really coastally mountainy, right? But we're concerned about our low-lying friends. And also, by the way, our wetlands do a really, really good job of protecting us from flooding events and could help protect us with mitigation for sea level rise. And so it's really important to protect those areas. If we look at other regions of the country, this is looking at Southeast Texas and Louisiana. So again, low-lying areas for our friends there. New Orleans ain't gonna do so hot. So this is a very, 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 very flat region. If you've never been there before, there's no mountains, no hills, no nothing. It's flat, flat, flat as far as the eye can see. So those lower-lying areas are gonna be the ones not doing well. Similarly, can be said for Florida, which is already actually facing impacts of sea level rise, and not great also for the Everglades National Park. Continuing on with ocean impacts, ocean acidification. So we already really dived into this idea pretty heavily when we talked about ocean acidification. So I'm not going to harp on this too much, but just know that it is a very powerful and concerning thing here. And just to remind us, it's the higher acidity in the waters which breaks down our calcium dependent trends. So shells, anything with shells, clams, mussels, oysters, conch, any of those nuggets, and then including coral. So coral needs calcium as well. And then of course coral bleaching. And this is one that is really visual. So you can literally see it when you go diving or free diving. And this is one that breaks my heart because you can see it in every reef, pretty much every reef. You can see the impacts of coral bleaching. So the reason that this is also highlighted in red, because I really want to emphasize here that coral bleaching is mainly due to sea surface temperatures increasing, not due to ocean acidification necessarily, though the acidification still stresses out the coral, right? So, but the reason that the zooanthellae want to leave the coral is due to the ocean just being too hot and the zooanthellae just being like, this is too hot for me, bye. And the zooanthellae are the plant part of it, and the colors, beautiful colors that we see in the coral. So no zooanthellae, you get white coral, and then the plant part, or excuse me, the animal part of it, the polyps, which look like little baby anemones, basically. Tropical coral cannot survive with just the polyps. Deep sea coral, however, are adapted to just having the animal part of it But yeah, so that's kind of a thing with that. So if a bleaching event occurs for too long, then the coral will die, and that basically eliminates an entire ecosystem. No questions asked. So this picture here is looking at a healthy reef versus a dying reef versus a dead reef, and notice the timing here just happens in about a period of 6 months. So that's not great, right? Whoops-a-doodle. So yeah, really, really not good for that. And so if you watch the documentary Chasing Coral, this actually dives into this idea pretty heavily. Last bit of potential impacts is immigration, and this is basically because of climate impacts or natural disasters that can happen, which could then prompt a family to leave an area. And so the onset of that is basically either slow repeated, sudden, medium, or sudden onset. And this map here is just trying to show where various countries have immigrated to, or where various people have immigrated to. Like Haiti and Mexico and Central South America are very high immigrators to the United States, as well as Philippines. Can't forget about them. But it's not just to the United States, as much as we love to think that we are the most important country in the world and that everyone just wants to be here. Other countries are experiencing immigration as well. So I encourage you to kind of consider and think about different natural disaster events that would maybe influence you to leave an area. If it's something that's quick, or if it's something, like sea level rise, where you'd be like, okay, well, I can't do that, or water shortages, and think of different adaptations that you could go through with that. So again, these are not all of the impacts felt with global climate change. These are just a few, some of the ones that I'm most passionate about. I'm assuming you can probably sense that through the video here, but it's I know it's kind of depressing, but it's okay. The next video will be a little bit less depressing. Promise. All right. So thank you again so much for watching. Cheers.